Hello everyone, lovely to be here on Viking.TV this evening. A lot of you will know me from cruising around the world as the whale and dolphin man, and for those of you that don't, I'll tell you a little bit about myself. I began this work as volunteer work really with International Dolphin Watch over 30 years ago, and I still act as cetacean consultant and education director there, but as many of you know, I'm now the Sea-Watch Foundation ambassador, having done a stint as regional coordinator. But as I say, best known on the ships as a naturalist and wildlife speaker. And if I'm not working on a ship somewhere, I'm generally working on a small boat somewhere, taking people out to see whales, dolphins and porpoises. So everything I've done has been as a volunteer. I was a primary school head teacher until a few years ago. I gave it up to take part more in the whale and dolphin research and to do my volunteer work and the work that I'm doing on cruise ships. So it's lovely to be here with you tonight. I'm going to share with you my talk, Fascinating Facts. And this came about while I was working with International Dolphin Watch. Dr. Horace Dobbs, now sadly no longer with us, had a series of children's books, and he came around one evening and said, "You're going to write an information book for children." And here it is, and he gave me the blank pages and kind of off we went. So you will see during the talk some really nice illustrations by a guy called Rick Oldfield, who is a wonderful illustrator, and there's some very nice, simple, straightforward illustrations to illustrate a few of the points I'm going to make this evening. Okay, well, lots of questions get asked as we're sailing around the world, and amongst them is, where do whales and dolphins come from? And it might surprise you to know that actually they originated from land animals. People know that life began in the ocean, of course, but some of it actually went back to the ocean from the land millions of years later. And a little animal called the Indo-Hyas is the ancestor of all of today's whales, dolphins and porpoises. But we're going to have a quick look at that evolution now. So there at the top in that little coloured illustration is Indo-Hyas, an even-toed ungulate, a hooved animal basically, kind of dog, fox, wolf-like if you like, and it began hunting in the water. It caught fish for food basically, and it's from that animal up to around 60 million years ago that the first animals started entering the water around about 55 million years ago. These animals, the Pachycetus, first found in the Pakistan area, and Ambulocetus, literally the walking whale. And you can see in the slide I have there that the Ambulocetus has already developed shorter legs, slightly paddle-shaped legs at the back, and a thicker tail to help it swim through the water. And we're going to have a slightly closer look at some of these creatures. And what it's going to show is that a gradual evolution from a four-legged land animal to a flippered sea animal with a large tail. So I'm just going to zoom in on that top part of that slide. And there's Pachycetus and Ambulocetus again. And there, as I said, these slightly paddle-shaped rear legs. What these slides don't show really well is that also at the same time, the blowhole, the nostrils basically, are moving back along the head. So most animals have their nostrils at the end of the head. But of course, if you're swimming along in the water, it's really difficult to breathe while your nostrils are underwater, clearly, if you're a mammal. So over millions of years, the blowhole nostrils moved further and further back on the head, so that as the animal is swimming along, it is easier to keep that nostril above the water. Now, these are all toothed whale ancestors, gradually getting closer and closer, and whales, something like the ones we see today, first started appearing around about 40 or so million years ago, probably something like that. The animals you see there as Dorudon and Basilosaurus. And now we have a much more elongated body, but there's still signs of those rear legs. They're only tiny, vestigial legs, but they are still there. But the front legs have become flippers, and now these animals are totally marine. They don't return to the land at all. At some point in between, some of these creatures flopped onto the land at times, much as seals and sea lions do today, for example. But by the time we get to Dorudon and the Basilosaurus, we have fully marine animals, and the whales and dolphins we know now started emerging somewhere around 35 million years ago. And one of the key developments, apart from the movement of that blowhole, was also having separated nasal passages. We can't eat underwater, basically, and please don't try that at home, just to test it. And the early animals wouldn't have been able to either. They would catch their fish and bring it onto land to eat. But to be fully aquatic, you need to be able to eat underwater. And so from Ambulocetus, the walking whale, onwards, the nasal passages were separated, and it meant that they could breathe, they could still eat without actually inhaling water all the time. Now, there is a little missing link here. All of these, as I say, are toothed whales, but we have, of course, baleen whales, blue whales down to little minke whales that don't have teeth, that have baleen. We'll look at that in a bit more detail, and I'll come back to that missing link in just a moment. But just to show that this fossil record is changing all the time, just last year, Abdullah here, Abdullah Gohar, had been working on a 43 million year old fossilized skull for a couple of years, discovered in the Egyptian desert. They've called it Phyomycetus anubis, and this is another whale ancestor, one of the earliest whales before we get the modern ones. A similar one was found in Peru in 2019 as well. And here's a close-up look of them working on it, and you can see the teeth. But what that skull also shows very nicely is that the nostrils aren't at the end of the skull there. They are well up the head now. See that big hole? That's where the nostrils, where the blowhole is on this large whale. Now, the missing thing was, how did baleen develop? If you're a toothed whale, still the case today, you catch just one fish at a time usually, but it seems that some of these whales were possibly developing a technique where they could try to suck in a larger amount of food, maybe a small school of fish or shrimps, just as Etiocetus here is trying to catch some fish. And if you look very closely, between the teeth is a small fringe of baleen. Baleen, we say in the UK, baleen, it's pronounced in the US. And this is keratin. It's the same as our fingernails. It is really just like a series of very, very long fingernails hanging from that upper jaw. And this is allowing the whale to close its mouth on a school of fish, and the teeth and the fish cannot swim out through the gap between the teeth. That little fringe of baleen traps them inside. And this whale, the Etiocetus, seems to be, at the moment at least, the first ancestor of modern day baleen whales. That, again, over a few more million years, this new technique of trying to catch schools of fish and sucking prey in rather than catching and biting it has enabled this fringe of baleen to develop. Now, this is the evolution of the whales, but just for the record, the nearest living relative would appear to be the hippopotamus, believe it or not. Like whales, they do actually spend a lot of time in water, but unlike whales, they still have the legs that the whale ancestors had and spend some time on land. And I'm going to show you in a moment a few pictures which really do give the idea of how they are almost like a whale in some ways, although Darwin actually described a bear swimming and hunting as being almost like a whale, not the hippopotamus. But this is an even-toed ungulate, a hooved animal. As I say, the nearest ancestor to Indohyus and all those very early ones, just developed down a different evolutionary path. And here we have a hippopotamus nudging its baby up to the surface for a breath. Its nostrils are not right at the end of its head, but they have migrated a little way back along the body. And there on the top right, we have a bottlenose dolphin nudging its calf up to the surface to take an early breath, and a humpback whale with its calf. So there are some similarities. And if you look at the mouths even, again, you can see a similarity. Now, just because they look similar, of course, doesn't mean they are related in evolution, but it does make it a little less fanciful, if you like. And there at the top right, the grey whale, you can see that fringe of baleen, which is probably a foot or so long on a grey whale, not such a small fringe as on that early Etiocetus. There is a hippo with its mouth wide open, a toothed animal, of course, but there is a false killer whale with its mouth wide open, showing its teeth. Head on, a hippopotamus and a northern right whale look amazingly similar, and you really do begin to get the idea that actually, yes, you could see they could be related. There's a few things. The blowhole on the whale is well raised out of the water. It's behind that fairly central patch. The nostrils on the hippopotamus are nice and high, so it doesn't accidentally breathe in water. And all of those hair follicles at the end of the hippo's head really do show quite clearly there. And those areas on the front of the whale, the callosities we call them, are basically hair follicles on the whale, which whale lice and other marine organisms have attached themselves to. And this is actually one of the ways that we identify individual right whales. The patterns of those callosities help us identify them from year to year. Now, whale research, you could say, arguably actually began with Aristotle all the way back in ancient Greek times, one of Alexander the Great's teachers, of course. And although he was ridiculed by some of his contemporaries for the ideas, he recognized that whales and dolphins were mammals and not fish. Of course they're fish, said his colleagues. They're swimming in the sea and they have tails. But he pointed out that they were breathing air. He could see them coming up to the surface, taking breaths, pointed out the tails were different. And of course, if you were a philosopher in ancient Greek times, it wasn't just about the human spirit, but you studied agriculture or medicine, drama, all sorts of things. And in his case, he went out to sea and started looking at whales and dolphins, amongst other things. And if you want to read one of his books, you can actually still get this on Amazon, believe it or not, Aristotle's History of Animals. Not written in ancient Greek, I'm glad to say. But he conducted field studies in the Aegean Sea, just like whale researchers do today. And again, just like modern day researchers, he recognized individuals by their dorsal fins, either for natural features, or if they got caught in fishing nets and things, he would maybe cut a small nick in the dorsal fin. No more intrusive, to be honest, than those people that bolt sensors and trackers and things to dolphins. Most people these days prefer to avoid those sorts of things, but we work with photo ID, of course, looking at the animals from season to season. So quite remarkable how much work was done even back in ancient Greek times. Now, one of the most popular questions I'm asked is, what is the difference between a porpoise, dolphin and a whale? And there's an easy answer and there's a long answer here. One of the answers is that actually they're all whales. Technically, scientifically, there are toothed whales and there are baleen whales. And all of the dolphins and porpoises and a few whales count as toothed whales, the others as baleen whales. And the easy answer really is about size. The porpoises are the smaller ones, the dolphins are the middle-sized ones, and the whales are the really big ones. Scientifically, there is a difference between a porpoise and a dolphin. A porpoise has a spade-shaped tooth, whereas a dolphin has a cone-shaped tooth. And there is a bit of a size overlap, which adds to some confusion. Really big species of porpoise can be as big as or even slightly bigger than small species of dolphins, but by and large that does hold true. And that word cetaceans we see at the top there is from the Latin cetus for large sea animal, but also from the Greek ketos, meaning sea monster. And so that word also dates back to those ancient Greek times. So it's basically size that differentiates them. But as I say, scientifically, they're all whales. And some of the animals we call whales, unfortunately, are actually technically dolphins. So the killer whale, or orca as we prefer to name it these days, is the largest member of the dolphin family. A pilot whale is another dolphin. And certainly the name killer whale as well is a name we often don't like to use now, because not all of them are whale killers. Some are, some specialise in hunting whales. But the research around Vancouver Island showed initially 2 different ecotypes, a resident group, which are entirely fish eating, and other transient types which will eat anything. There is now also an offshore type recognised there. There are 5 different ecotypes at least recognised in Antarctica. And here in the UK, we have different ecotypes as well that visit our coast. So lots of work going on all the time. But those killer whales, those pilot whales, actually dolphins. As I said, they're divided into 2 groups. Toothed whales would include the sperm whale, huge sperm whale, 15, 16, maybe even 17 metres for a really big one. Bottlenose dolphins in the UK up to about 4 metres, maybe 3 metres in warmer parts of the world. Sperm whales only have teeth on their lower jaw. Bottlenose dolphins, all dolphins in fact, teeth lower and upper jaw. Similar shape as well, that kind of cone shape if we have a really, really close look at them. Just a difference in size. Another thing Aristotle can be given credit for is actually classifying them into these 2 types. The Mystakokitos, the mysticetes, literally translates as mustached whale. And again, that's that fringe of baleen you can see in the jaw of the humpback whale there on the left-hand side. Fairly long baleen on a humpback. And on the right, we have 2 odontocetes, or odontokitos, toothed whales, a common dolphin at the top there, and a sperm whale there. So scientifically, as I said, they're all whales divided into mustached and toothed whales, baleen whales and toothed whales. Now, I can't tell you how many different types of dolphins and whales there are. That's another question I get asked from time to time, because scientists basically can't make their mind up, and because we keep finding new ones, and also splitting species we thought were just one species into 2 or even more, and actually sometimes even recombining species that we had separated. Common dolphins, for example, there were long-beaked and short-beaked. They're now considered to be one species. We've discovered new species of baleen whales, but as you see, the various species are divided into families, and then within those families there are also different groupings as well. But around 75 toothed whales, around 15 baleen whales, including perhaps as many as 36 different species of oceanic dolphins, for example, in the toothed whale category. But let's not dwell on that side of things. Let's start looking at some of the more interesting facts, and one of them is the blowholes. Blowholes are, of course, basically just their nostrils. These are air-breathing mammals. Unusual, of course, for an air-breathing mammal to live mainly underwater. So, of course, they have to come to the surface to breathe. And all of the baleen whales have 2 blowholes, arranged in a way a little bit like our nostrils in some regards, I guess. You can see the bridge of the nose, if you like, which is the splash guard, and the 2 blowholes there on the blue whale on the top right, and a harbour porpoise on the left down at the bottom there with just a single blowhole. But in both cases, they have a natural resting position of tightly closed. And whales and dolphins, porpoises are all conscious breathers. That means they have to make a conscious effort to be able to breathe. They have to be awake and conscious. And that makes sense if you think about it, because if the blowhole could just be open naturally, you could very easily drown yourself while you are underwater. They're underwater for far more time than they're on the surface. So it makes sense for that blowhole to be naturally closed. And as they come to the surface, they can sense that the blowhole is now in the air, that the water is being pushed away, and they can blow out really hard to blow out any residual little bits of water that may be gathered around the blowhole, take a deep breath in, and then as they roll forwards, those blowholes will be tightly closed very, very quickly, just before the head goes back into the water. Now, I've mentioned baleen a couple of times, and here's some baleen on the left-hand side there from either a right whale or a bowhead whale. These were the whales that were targeted by the whalers in the 17 and 1800s in particular. And you can see how long that baleen is. On a right whale, it can be up to 2 meters in length, that's 6 feet or so. On a bowhead, can be as much as 3 meters, 9 feet or so. So it was very, very useful stuff because it's, as I say, it's keratin like your fingernails. And if you can imagine how bendy and springy your very long fingernails are, the baleen is much thicker and stronger than even that. So, of course, famously, it was used for ladies' corsets, but it was used for the tines of umbrellas, for example. In fact, anything you can imagine where we might use plastic today, chances are baleen was in use. Hairbrushes, for example, chimney sweeps brushes. All made from baleen, and it acts as a filter, as I said, when the whales are eating. We'll come back to look at how whales eat in a little while, but here on the right is baleen from a sei whale, probably 30-40 centimeters in length, maybe a little bit longer than that, 1.5 foot maybe, and you can see the kind of hairy ends for it. And if you can just imagine with the whale with its mouth closed, the water can be squeezed out between these plates, but any little fish or shrimps get trapped inside the mouth. And that's the primary function of this baleen. Size matters, they say, or they sometimes say it doesn't. Well, the little and the large would be the blue whale at one end of the scale, the largest creature ever to live on our planet. Absolutely vast animals, 33 meters or so long, over 100 feet in length for a big blue whale. The vaquita is the smallest of all of them. It's a type of porpoise, only found in the Gulf of California, and sadly pretty close now to extinction. There are fewer than 30 left, many of them caught in fishing nets by accident, illegal fishing for the totoaba fish, which is highly in demand for Chinese medicine for its swim bladder, amongst other things. So despite all of the efforts to save it, there are sadly very, very few of them left. But those 90 species vary in size to that extent. And just as a quick comparison, I won't dwell on this, but I found this wonderful slide from the National Geographic just to compare some sizes. There is a blue whale towards the bottom there, with a whale shark, which is the largest of all of the fish. There's the sperm whale and its main prey, the giant squid, at the top. And if you look carefully, in the middle of that giant ocean manta ray is the puny human diver in comparison to these wonders of the deep. And a similar slide, which I also like very much, looks comparing it with some of the dinosaurs, as people sometimes say, surely the dinosaurs were even bigger. Not even close. We've got a Brachiosaurus and a Tyrannosaurus Rex down towards the bottom left there, and one or two prehistoric fish like the Shonisaurus there still don't even get close to the size of a blue whale. And I will just point out, next to the blue whale, the orca there. Believe it or not, even a whale as big as a blue whale, usually the calves, but sometimes even adults, do get attacked by roving packs of orca that would class as killer whales, some of the whale predators. But it's to do with the skill and intelligence of the orca and its hunting ability that makes that possible. So a few fascinating blue whale facts then. Blue whale calves are big, and blue whales are big, but 7 meters long is a big baby, 3 tons of baby in fact, and in a month it's going to double in size. Absolutely remarkable. And again, 2.2 pounds to a kilogram, so you're looking at about 220 pounds a day in growth. Now, to do that, the whale needs an awful lot of milk, and of course these are mammals, so whales do suckle their young with milk from 2 nipples, which again I will show you roughly the area of that on a later slide. But a lot of milk that needs producing, and like all whales, this blue whale mother will be actually producing that milk from her own body fat. She's metabolizing her fat to produce the milk. It's why whales have to eat so much when they're on the feeding grounds. So they've put on enough fat to feed them in the warmer waters where they can't feed. And another interesting fact, I think, while we're looking at blue whales, not just on the size, the loudest voice of anything in the animal kingdom. We can't actually hear them. Their voice is well below the range of human hearing generally. Certainly the really loud noises are. But they think that at one point they could probably communicate over 1,000 miles or more. But since the days of sail ended and the seas became full of ships with motors, then sound now does not travel so far. So probably only over 200 or 300 miles, we think. And actually, just as an aside, it's an interesting idea that studies of right whales have found that they're actually communicating about 2/3 of an octave higher than they used to do in order to get their communications over the noise of all of the engines in the ocean. Now, we've looked at the sperm whale on a couple of occasions, so here's some more interesting facts with the sperm whale. They regularly dive to over a mile, mile and a half on occasions, and although the normal breath hold is probably 45 minutes to an hour while they're diving, they have been known to be down there over 90 minutes while they're hunting for giant squid, and they're hunting for them using that amazing sonar ability that they have. All the toothed whales have some sonar, but that of the sperm whale is quite phenomenal, and I'm going to come back and have a little look at that. But that amazing shaped head is full of an oil known as spermaceti oil, and that's what gave the sperm whale its name. When the hunters were first taking them, when they cut the head open, they found this milky white fluid, vast quantities of it in the forward part of the head, and they thought it was basically sperm, and hence the name sperm whale. But it's nothing to do with reproduction at all. It's an oil that is used to help with the refining and direction of the sonar, and again, as I say, I'll show you a slide of that in a minute. But it became a really important product. Sewing machine oil, for example, was sperm whale oil for a long time, spermaceti oil. Early brake fluids, automatic transmission fluids, we couldn't refine mineral oil fine enough to make those sorts of oils, so it was spermaceti oil for a long time, right up into certainly the 1960s, even into the 1970s. Sperm whale oil was a large part of that. From that point on, we began to refine mineral oil well enough, and so it wasn't necessary to hunt sperm whales anymore. The blowhole on a sperm whale is offset to the left. All of the others are sort of central and back on the body. It's offset on a sperm whale. Again, we guess probably because they come back up from deep underwater relatively rapidly. They have to be careful not to come too fast, because potentially they can actually get the bends. It wasn't thought that they could, and we think that the blowhole has evolved to that position just so that it gets a breath as soon as possible when it comes up to the surface. Remarkable adaptation to be able to dive so deep. Of course, they're able to collapse their lungs, higher levels of myoglobin, so they absorb a lot less nitrogen than a human diver would, but still quite remarkable. And here's a cross section through the sperm whale's head. It's not a very sharp image, that, I'm afraid, but you can see the top half of the head, all of that yellow area is the spermaceti oil in that capacity there. And basically the whale makes a little bit of noise with these things called monkey lips near its blowhole. It passes through the spermaceti oil, is reflected off an air sac and a kind of reflector at the back of the head there, and goes out through what are in effect a series of lenses in an area of the head the whale is referred to as the junk. And the sound goes out and it comes back in and is received through a sort of pad of fat in the lower part of the jaw. And there's a slightly sharper image just copied there at the bottom, just a slightly different view of it, just to get the idea of both the cross section through and how that's happening. And this sonar is certainly until quite recently was far more sophisticated and capable than anything we could do, and it's able to be not just used for navigation, but actually even to stun prey. And the prey, if they can catch it, is the giant squid. They will eat smaller squid, and they will actually even eat fish if they have to, but giant squid is certainly the preferred prey in deep canyons. And interesting creatures, giant squid, very, very little brain to control such a huge animal. And why such a large penis, and why am I talking about it? Well, I just love this quote from a gentleman called Steve O'Shea from the Auckland University of Technology, who described described giant squid mating. And he describes it thusly. I'm going to read this. He plunges the penis into the female's arms, which unfortunately are right next to her beak. Because he is coordinating so much with so little, occasionally bits get chewed off. So as I often say, it's not easy being giant squid, clearly. And here's a wonderful image from a diorama showing what we think the battle between a sperm whale and a giant squid might look like. Okay, let's look at the brain. Brain science is a fascinating study in its own right, but there's just a slide showing the different sizes of a few brains in the animal kingdom. Largest of them in the sperm whale, largest brain on land is the African elephant. The picture at the bottom there is my wonderful wife, Chris, and she needed me to point out that, of course, the female brain is superior to all of them. The best brain to size ratio, actually, believe it or not, is shrew. Now, that really indicates that it's not all about size, and you need a brain of a certain size just to manage your body. So it's the complexity of neural pathways and the various features of the brain, but size is a good starting point. And this quote from Douglas Adams really sums up for me in a humorous way what we need to think about very carefully when we're talking about brain size and intelligence, because we tend to measure intelligence by the things that we do and the things that are important to us. Whereas if you are a dolphin or a whale, your intelligence is used in a very, very different way. As Douglas Adams said, what appears to be to muck about in the water having a good time. But the dolphins believed they were far more intelligent than man. What is interesting, though, is if you compare a dolphin brain on the left with the human brain on the right, you find that they are similar in a lot of ways, but actually the dolphin brain has a greater complexity in some parts, particularly in the neocortex. And that neocortex is the part of the brain which is responsible for empathy and understanding past, present and future and relationships and all of those sorts of things. So, there's certainly a capacity for intelligence in the dolphin, which is at least as great as ours, which is food for thought. But they use it very differently, and one of the things they do very differently is they don't sleep the way we do. I've already indicated they're conscious breathers, so they can't sleep, and they're able to rest one half of their brain at a time in order that they can stay alert and able to breathe. They'll hang in the water, maybe lying flat at the surface with their head just at the surface or just below, so they come up every minute or two, or a little bit longer maybe even, to take a breath and then drop again. Or they'll hang at an angle in the water with the blowhole at the surface, or even swimming very, very, very slowly forwards with a little degree of alertness of what is around them, at least, because half of their brain remains awake. Okay, feeding. Well, they eat an awful lot of fish, of course, but actually, interestingly, although they eat a lot of fish, because they also, we would say poo in the UK, poop in the US a lot as well, that's a really vital part of regenerating the oceans. And so although they are eating, they are actually recycling that all of the time as they are swimming around. And plant organisms and much smaller animal organisms are actually feeding on that in order to restock the ocean even as they are eating. So different amounts of food depending on the amount of activity. And of course, a lot of the baleen whales don't eat at all in the winter months when they're in the warm waters breeding. There is no food there for them. They have to go to the colder parts of the world in order to find their food. So, 4 million krill in the case of the blue whale, 3,500 kilograms a day. That's about 7,700 pounds if you prefer that measurement. Dolphins, again, depending on how active they are and of course how big they are. A smaller dolphin is going to be eating less than a larger dolphin, but there's at least some guidance there of the sorts of amount you might be eating. So the bottlenose dolphin is well known. If I just take that one, around 10 kilograms a day for a very small one that's not very active, through to perhaps 45 kilograms a day for a large active male dolphin. And that's between 22 and 99 pounds per day. So yeah, a good amount of fish. Here's a nice cross section through a baleen whale's mouth, again, just to see that how that works. You've got the black area there are those baleen plates we were looking at in the earlier pictures. The rostrum is the upper jaw, and then you've got the lower jaw there with a lot of muscle in it. And of course, often they have these grooves in the jaw area so that the whole jaw area can be expanded in order to get a lot of seawater and a whole school of fish inside the mouth. The tongue is then used to squeeze the water out through those black plates, those baleen plates that we've seen the images of. And then once the water has been squeezed out, the fish can be swallowed. So it leads to two completely different ways of eating for baleen whales and toothed whales. Toothed whales, like the bottlenose dolphin eating a salmon on the top left there, will eat one fish at a time, and they won't chew it. They'll catch it in those teeth, and they might bite a chunk off it, and they have even been known to share food with other members of the pod. Particularly if you've got sick or injured ones who've not been able to catch their own food. A baleen whale, again, we've got an illustration on the right hand side, a humpback whale in the image on the bottom left, showing that a whole school of fish is captured in this vast open mouth. And so there's a close-up of that salmon going down the bottlenose dolphin's jaw, and there is the humpback. Again, you can see the baleen plates quite clearly in that. And once the jaw is closed, all that water will get squeezed out. Of course, the various gulls there hanging around have seen what the humpback whale is doing and are just trying to steal a few bits of food before they get swallowed too by accident if they're not careful. Now, different techniques have evolved, and again, it's a whole talk in itself to look at the different techniques different whales and dolphins have developed, but just to cover two fairly quickly. One quite famous one is the humpback whale bubble netting, and it's important to stress that not all humpbacks do this. It's a technique that was first seen only in the northern parts of the Pacific, around Alaska, but has actually spread to other whales. Once the first group was seen, it was realized that certainly one of the females seemed to be going to other groups to teach them how to do it too. And we have also this technique that dolphins use of making bait balls. So here's the humpback whale in the middle of that string of bubbles. You can just see that a number of whales, perhaps 4 or 5 of them, have been swimming round and round a school of fish, blowing bubbles to confuse the fish and keep them trapped inside. Another whale has been underneath them, forcing the fish up. And at the last moment, the whales burst through this trapped school of fish. But dolphins will do much the same thing, and I've seen film of orca doing it, exactly the same thing. They will use the natural habit of fish to school tightly together for protection. And once in such a tight ball, it makes it a lot easier to just dive into the ball and catch fish, rather than having to chase a lot of individual tiny fish swimming all over the place. If you can get them all tightly in one place, it makes it a lot easier. And of course, for a big humpback whale, even easier still, because it can catch a whole number of those all in one go. Okay, moving on, mating. Well, here we go again. He's talking about male organs once again. Why? Well, there is a reason for in this case. I mean, one, it's an interesting fact. 3 meters is quite long. And if you've never been, and I've got to say I've never actually been myself, although I know where it is, there is actually a phallus museum in Reykjavik. It used to be at Husavik. And phalluses from all sorts of animals, including humans, can be viewed by anybody who wants to do so. But although it's not quite as big, in a southern right whale, what is remarkable is that the testicles are about 10 times the weight of the much, much bigger humpback whale, much bigger blue whale, I apologise, and weigh around 500 kilograms each. And it could well be that the size of these sexual organs is part of the reason why the southern right whale is one of the species, if not the species, which has recovered the most strongly since the whaling years. They've calved regularly. They're very promiscuous in their mating habits as well. It has to be said, that's part of the story as well. But those populations have recovered far more quickly than any other species anywhere in the world. And I'm sure the size of those sexual organs must be a big part of that. Now, with all whales and dolphins, they're actually, unusually for a mammal, born tail first. That enables the animal to swim very quickly to the surface once it's born, often helped by another female. You don't get the chance to film and see this in the wild, so unfortunately this photography is from a dolphinarium, from captive animals, which is not something that I would normally share. But in this instance, to actually see how the dolphin is born, it's quite a remarkable series of films by the Chicago Zoological Society. So I'm grateful that we can actually see it. And it shows quite clearly there that there is another female. And in the wild, this is what would happen. Perhaps an older daughter of the mother, perhaps a totally unrelated dolphin, will often actually assist at the birth. And by being born tail first, it gives the tail time to spread out and start to beat more strongly. And it means the baby is swimming in the same direction as its mother when it's time to go up to the surface. And as I mentioned earlier, they are fed on milk from the mother. There are 2 nipples either side of the urinogenital slit on the females, and the baby will push its beak, or its mouth if it doesn't have a beak, really tight into that slit, and the milk will be squirted at high speed, really thick, rich milk will be squirted straight into the baby's mouth. So it doesn't actually suck it, it's actually squirted out there by its mother. And depending on species, they will be suckled for around 6 months, maybe 3 years or more. There have actually been records of bottlenose dolphin mothers still nursing their offspring at even 4 or 5 years, but by then they are able to actually catch their own feed as well. How long do they live once they're born? Well, again, it varies massively with species. Porpoises, smaller animals, tend to live shorter lives. Around about 15 years is expected, but they're very coastal in the case of harbour porpoises, so they come into contact with human waste, fishing nets, disturbed seabeds, lots of vessels and so on. So they actually probably only live about half as long as they should do. The oldest bottlenose dolphin we know has lived to about 64 years. And as the studies go on, we'll probably be upping this average. It's a little higher than the average that Aristotle first calculated, but at around 50 years for females and 35 for the males, it's not far off what Aristotle said. And as I say, longer term studies now that have been going since the 60s or 70s are beginning to suggest that actually it's probably a little bit higher on average if things go well. Bigger whales, well, again, long-term studies of the orca around Vancouver Island, we know that they live for 90 years or even longer in some cases, and males living for at least 50 years. And bowheads, probably the most long-lived of all. We're looking at the moment that maybe over 150 years some of those whales have been on the planet, the things they must have seen. Now, one of the greatest sights on a cruise has to be dolphins coming racing to the ship, coming to ride the bow wave. Of course, like Dilo in Horace's story there, illustrated by Rico, once they are close to the bow wave, you can't see them, of course, because they're hidden by the bow. But what's happening down there is that the bow wave, the pressure wave there, is pushing the animals along at a speed that they couldn't achieve without expending an awful lot of energy. And so although they can keep up with a ship, I mean, mostly cruise ships tend to cruise at 17 or 18 knots. I've rarely seen the Viking ships go more than 20. They can do if they have to, but it's much more fuel efficient to do sort of 17, 18, 19 probably. So the dolphins have to work really hard to keep that up. But once they're on the bow wave, they're being pushed along easily. And just look at surfers in a wave and you'll understand how easy it gets to be for the dolphins there. And they used to do this with the great whales on migration. They would actually ride the bow wave of the whales as they migrated. And so they've learned that they can do exactly the same thing with the ships. Of all the dolphins, the fastest is the orca. They have been measured with burst speeds of around 30 knots, which is nearly 35 miles an hour. Not something they could sustain, but the little Dall's porpoise has been known to match it, which is a good thing because in the Northeast Pacific, Dall's porpoise are one of the prey of those oceanic and transient killer whales. Fin whales, second largest of the baleen whales, are incredibly streamlined and also very powerful swimmers, and they can sustain a good 20 knots, have been recorded at around 25, so quite remarkable speeds. But hopefully next time that you are cruising, you will have the joy of seeing dolphins. If not riding the bow wave itself, they'll sometimes drop down the side of the ship and ride in the waves alongside. And if you're on that wonderful deck 7 forwards in front of the Explorers Lounge, standing on the bridge wing and looking down, you can often see the dolphins that have left the bow wave drifting back down the side of the ship to ride in the bow wave alongside or to drift back towards the wake. So a great place to watch them from. Okay, getting towards the end of the talk now, we're going to look at a few other animals now. We've had a good look at some of the wonders of whales and dolphins. And I've described this as Britain's biggest seabird. It's actually the North Atlantic's biggest seabird. The northern gannet can be found all the way across to Canada and the US as well. And there are 2 species of gannets elsewhere. There's a Cape gannet in South Africa. There's an Australasian gannet down in that part of the world as well, which are very, very similar. And we're looking at a 6-foot wingspan of these amazing creatures, but they're very closely related to boobies. And again, if you've sailed in any tropical and subtropical areas, you will be well familiar with the boobies. We have the masked booby. There's a very similar Nazca as well, which looks remarkably similar, of course, to the gannet. Little smaller than gannets, but very similar. We often see them chasing flying fish. The Peruvian and blue-footed boobies, quite famous, of course. You've probably seen a lot of brown boobies around the Caribbean, but in the Pacific side too. And this is a fairly immature red-footed booby, which also come in a beautiful chocolate brown colour and also in a white colour, not dissimilar to the masked booby. So they're all very closely related birds, none as big as the gannet. But going back to the northern gannet, and indeed all of the boobies, when the babies are first born, they are not in their full adult plumage. They all of them take at least 3 years, but in the case of a gannet, 5 years to go from a brown bird when it first takes flight to the wonderful plumage that we later see. And this gannet, for example, is probably about 3 years old. So you can still see it's got a lot of its browner coloured feathers, may even be nearly 4, this one. But there's a lot of brown feathers still on its back. There's still a lot of brown feathers on the trailing edges of its wings. And each season when it molts, it will get more and more of its white feathers until it has this amazing colour. And that golden head gets really, really vivid, when it's in the breeding season. And what they're chasing around the ship, of course, is flying fish. Excuse me, flying fish are not actually technically flying. They are actually gliding, and what they're doing when they're skimming along the surface is they have leapt out of the sea because they have a fish chasing them. Now, why we see them on the cruise ships is that they, poor little things, think that the ship is actually chasing them. So they leap out of the sea to try and escape, and the boobies have learned that they're going to do this, as they have done since they've probably followed sailing ships doing exactly the same thing. So they'll ride the air currents with the ship, wait for flying fish or a whole school of them, but sometimes to leap out of the sea, to glide away from what they think is a predator, and then they'll just swoop down and snatch them, or even dive into the sea after them if they need to catch them. And you'll watch them, sometimes they'll zigzag away, they'll hit the water and then take off again, and basically they'll wiggle that tail really fast. And you can sometimes see a kind of zigzag pattern in the water where the fish hasn't gone right back into the sea, but it's just used its tail to give it a bit more speed again and drift a little bit further. But in one drift, they have been measured at going up to nearly 200 meters. So again, a bit more than that in yards, or sort of 650 feet or so. And a 45-second glide has also been measured. Big ones up to 1.5 feet long, but most of them are quite a bit smaller than that. Whale sharks, we have occasionally been lucky to see one from the ship, but there are various parts of the world where you can go on a tour to see them. And these are the biggest fish. 14 meters is up to about 45 feet in length for a really big one. Most of them probably 6-7 feet smaller than that. And absolutely incredible creatures, called whale sharks just because of the whole size of them. They're not a whale, they're not, they're a fish, they're not a mammal. But because they filter feed, it is considered a sort of similar feeding style, if you like, to a baleen whale, and the whole sheer size of them just means that whale shark seemed like a suitable name for it. An animal that size would probably weigh in excess of 20 tons, but most of them, as I say, a little bit less than that, maybe up to 30 feet or so long, 10 meters or so probably. And they filter plankton. They don't even eat anything as big as fish. They're actually just filtering plankton as they swim slowly along. And I was lucky enough to get the chance to actually swim with a whale shark with a researcher in St Helena on a trip I was on some years ago, which was quite remarkable. And these are the pictures I took from the side of the boat. Now, the whale shark might be the biggest fish overall, but it's cartilaginous, as all sharks are. It doesn't have a bony skeleton. And the largest of all of the bony fish is the mola mola. That can weigh 2,000 kilograms, 2 tons basically. And the big one can be 3.1 meters long, so 9.5 feet or so. We even see these in the North Sea now, particularly as the oceans are warming a bit, but we don't see them anything like as big as that. The ones we see are no bigger than sort of foot or 18 inches at the most, generally speaking, in our part of the world. But in the warmer waters particularly, you can get some really, really large ones. And there's another of Rico's lovely images, but what a wonderful photograph of the mola mola that is. Another animal we can even see from the ship, and in the right parts of the world, we have seen quite a lot of turtles over the years, just drifting past the ship as we've sailed the 7 seas. The largest of all of the 7 species of turtles are the leatherbacks, and they're also the oldest species. These go back 150 million years, again to the time of the dinosaurs. So amazing ancient creatures which specialize in eating jellyfish. All the different turtles have preferred food, and because they specialize in jellyfish, they are particularly prone to death from plastic pollution, because they mistake plastic bags for jellyfish, unfortunately. The second largest of all the turtles, the green turtle, not actually called green for the colour of its shell or anything like that, but actually for its fleshy colour, blood and flesh colour. But again, this another specialist, primarily vegetarian. They eat seagrass and algae mainly, but they will eat small sea creatures as well on the occasion. So there's a close-up of a leatherback, unlike any other turtle. Some of the others can be a little difficult to tell apart, particularly from the deck of a cruise ship. Much easier if you are really close to them. That's the green turtle as well. In the Mediterranean, in my part of the world, nearest place where there's a number of turtles, although we do see leatherbacks coming all the way across to Britain sometimes, but loggerheads are the most common in the Mediterranean. And they're a shellfish specialist. And again, if you look at the mouth of that animal, you can kind of see from the shape of it that its mouth is sort of adapted for crunching into shells of crabs and mussels and such like. And in all cases, these turtles come back to the beaches that they themselves were born on in order to lay their eggs. Varies with species, varies with how well they've managed to feed, but from 2 to 5 years, every 2 to 5 years, they will come back to the beach, lay their eggs, hundreds of eggs, and after around 60 days, the little hatchlings will come out and make their way to the sea. And of course, on their way to the sea, lots of predators will try to take them. It's an amazing food source. Again, part of the wonders of nature. It's why turtles lay so many eggs. It means that at least some of them will hopefully survive. Of course, if we get involved and start harvesting them as well, or if we damage the oceans, then we upset that very fine balance. Another interesting fact, just a couple more to finish off with. Seaweed, of course, is not really a plant at all. It's a type of algae, and as a result, it doesn't actually have roots. So we talk about holding fast. Well, they have what are called holdfasts, which help to attach them to the rocks. And of course, there are many different types of seaweed on the seabed or attached to rocks along the coast. This is probably the best known of all. It's the bladderwrack. Certainly in my part of the world, UK, Europe, the bladderwrack is way the most common seaweed, but lots of other places around the world too, as well. Canaries in the Mediterranean, for example. And bladderwrack was really, really important. It was actually the first source of iodine. And iodine was really, really important for treating a goiter, which is a swelling of the thyroid gland, which there's a little picture at the bottom there. I'll show you a sort of closer look. But going back to the roots thing, they're not having roots, just have these holdfasts. So they're not taking up water or nutrients through the plant. It's just being absorbed through the surface tissues of the algae and, of course, from the all-important sunlight. So there's a real close-up look of the bladderwrack, and there's this unfortunate lady with the goiter, which was treated primarily by iodine. And our final creature is again one that was inspired by Horace's book and the little book for children that we wrote. This is Dilo conducting an orchestra of what he called clop-clops. And anybody who's dived, as Horace had, will recognise that this is a behaviour that you can see in scallops. If anything gets close to them and they feel threatened, they will clap the shells together and bounce on the surface to try to escape from the danger. And in fact, if they really need to get a distance, they can do a very one single very strong press together of the shells and emit a jet of water and travel quite a distance at speed, propelled by that jet of water. So this little creature, which a lot of people would regard perhaps just as food, has an incredible sensory system. Very, very simple creature. There you can see it inside the shell, a very, very simple basic creature. But all around the edge of that shell, in order to sense danger, is a row of tiny, tiny little sensors to notice movement, change in light, in order that it can then either just close itself up to avoid the threat, or in real extremis, as I say, clap the shells together to bounce around, to hopefully scare off the predator, or to expel that jet of water in order to travel away. And of course, the fishing methods that are used to capture scallops, which are basically big rakes on the seabed that scoop them all up, no longer do single divers go down and pick them carefully from the seabed. They're raked up by industrial fishing. Is one of the most damaging fishing methods that there is for anything. So I hope you've enjoyed that. I look forward very much to sailing with you again. I will be doing British Isles cruises on Venus, July 29th and August the 12th. Bergen to Greenwich, then Greenwich to Bergen. I will be on the Neptune on December the 8th, doing the transatlantic from Barcelona to Fort Lauderdale, where I'm going to be on the world cruise from Fort Lauderdale to London, starting on December the 23rd, right through till May. So more cruises to come the following year. So hopefully you'll be able to sail with me at some point. If not now, at some future point. But until then, if you'd like to stay with us for just a little while longer, we're going to have a few questions. Thank you for now.
Thank you, Robin. Yes, we've got plenty of questions for you today. Our first question comes from Ronald, who is in Dallas in the US. And he asks, what are the best locations and best times of year to observe a breaching humpback whale?
Wow. Well, from your part of the world, you've got two reasonably good, well, I suppose you could say three reasonably good options. You need to be there in the summer months, but going up to Cape Cod area, sail from Providence or out of Boston, any of those parts of the world, they are really good places to see humpbacks feeding, and if you are lucky, also breaching. They would be the nearest places. For those of us in Europe, Iceland is probably about the best place to head to. If you want to look more at the west coast, again, you could do a lot worse than going to any area around Alaska during those summer months when they're up there feeding. But if you want to head to Hawaii for a holiday, I've seen plenty of them breaching there. Of course, they go to Hawaii in the winter months, which is where they head to breed. So I guess those would be the places if you're looking to go from America. And then, of course, the other well-known places for humpbacks would be around Australia and South Africa. Again, they're there in the winter months rather than the summer. They head down into the Antarctic in the summer, which is a little bit more difficult to get to.
Thank you. And we've had a comment come in for you this today, Robin. It comes from Sylvia, who's from Houston in the US. And she says, "Hi, Robin. I remember you and your wife from the World Cruise in early 2019. I enjoyed your daily lectures and whale and dolphin watches in the Explorers Lounge. It's so good to see that you're still lecturing with Viking."
Oh, that's smashing. Thank you very much. Yes, I mentioned a little bit ago, we've been very, very fortunate to being able to join all of the world cruises so far. I was due to be on this one. Unfortunately, COVID issues intervened slightly, but I'm due to join the next one. But I took part in the first one. I've been working with Viking since the very first transatlantic on the Viking Star, which was the wake of the Vikings, sort of Bergen to Montreal. And I love working with people on the ships. The Explorers Lounge, with Chris and I do whale and dolphin watches at least 2 hours every sea day, but anybody who knows me knows we're there pretty much most of the day. If anybody knows the general manager, Sujith, when I came for the second world cruise with Sujith, he greeted me at the gangplank with the words, "Robin, we haven't bothered getting a cabin ready for you. We've put a hammock in Explorers Lounge for you." So yeah, my reputation precedes me, I'm afraid.
There we are. And our next question for you, Robin, comes from Bonnie, who is in the US. She asks, when a whale sleeps, does he close his blowhole and stay under the water, or do they stay on the surface?
Little bit of both, and it varies. The exact sleeping technique does vary with the species, but in most cases they can do either. I mean, remember first of all that the natural position of the blowhole is always closed. So whether they're on the surface or below the surface, the blowhole is mainly closed. And then if it's below the surface, and they will sometimes rest just below, so they are not visible at all, or even if they are only barely. And then, then part of their brain is awake, so it moves them up to the surface, take a breath, open the blowhole, breathe out, breathe in, close the blowhole, drop under the surface again. Or they'll sometimes do what we call logging, which is basically lying at the surface. So the head and the blowhole is out of the water, but it's still closed most of the time. The waves could lap over it, etc. So they'll only open it, take the breath, and close it again, using that half of the brain that is awake to take that breath. And similarly, dolphins as well, sometimes will lie at the surface, sometimes just below, and just come up, take the breath, and drop down again.
Thank you very much, Robin. And our next question for you comes from Edna, who is in Atlanta in the US. And she asks, why do sperm whales have a preference for squid?
It's a good question, but most animals do have a preferred prey species, and that's just the way it has come with sperm whales. They find everything they need in those squid. There's quite a lot of water in the body of them as well, of course, and all marine animals take in their water through the prey that they eat as well. But animals kind of evolve over time to specialize in the prey that they can find in the area that they are. And sperm whales have evolved to be a deep ocean creature. They rarely come anywhere close to the shoreline unless it's an unusual area where there's a deep canyon that brings them close to the shore. And, out in those deep waters, far from anywhere, squid are quite plentiful, especially in the deep ocean canyons, and they have no competition, or very little competition at least, should we say, for that prey. So by specializing in eating squid far away in the deep oceans, they're avoiding competition for their food source from other species, and they've proved to be very successful at it. As I say, they will eat smaller squid. It's not just giant squid, but that's certainly the preferred creature. And the larger creature they can catch, in one fish, then that's obviously better than having to do a lot of chasing of a lot of smaller ones. But if necessary, they will take fish as well, as I say. But it's any animal basically. I mean, lions on the savannah, whatever, they have a particular prey animal that is their main source of food, and for the sperm whale, it has just evolved to be the squid.
Thank you. And our next question for you comes from Richard, who is in Pompton Plains in the US. He asks, how much do the migratory patterns differ between, sorry, let me read that one out again. How do the migratory patterns differ within a certain species?
Well, if we take one species, let's say let's take a humpback whale, which is the sort of really well-known migration. You've got different populations that have specific routes to them. So most of the population of humpbacks that you see around Hawaii migrate only between Hawaii and Alaska. So they mate and breed in Hawaiian waters and then head up to Alaskan waters, and they won't go anywhere else, basically. In the Atlantic, we have some Caribbean, if you like, humpback whales. The majority of them migrate up the eastern seaboard of the US and Canada. Some of them go more transatlantic, and we actually have some migrate along the coast of the UK and head up to sort of northern Norway and Iceland. We have a few that feed around the UK as well. And then the southern Atlantic populations of humpbacks, again, have particular routes that they don't deviate from. South Africa to Antarctica, certain parts of Antarctica, Australia to different parts of Antarctica, South America to even more different parts of them. And then interestingly, we have a population of humpback whales up in the Arabian Sea, perhaps 100, 120 of them. Anybody who's sailed up in that part of the world, those whales don't migrate at all. They're the only humpback whales in the world that don't migrate, or at least as a population that don't migrate. So the northern and southern hemisphere humpbacks never meet each other. And this is probably true of most of the other species as well. They have their set migration routes and patterns. Now, what does happen to some extent, and is happening because of climate change, changes in ocean currents, changes in prey availability, is that if the food source they need isn't there, they will change that migration pattern, they will change that route, they will try a different area to find food. But that's a major undertaking, because, for generations of whales, hundreds, thousands of years, maybe even millions of years, those whales have followed those routes. And, suddenly over the space of the last 40, 50 years or so, certainly no more than 100 years, massive changes have happened. And so some of those migrations are changing. And then just as an aside, I mean, I've mentioned humpback whales, we've got other things that migrate, of course, as well. The little Arctic tern and the slightly bigger sooty shearwater, two different bird species, actually migrate from pole to pole each year. So, you know, they're actually traveling the whole length of the Earth and never see winter months and dark skies. They just head from one end of the world to the other, feed and breed at opposite ends of the world. Quite remarkable, some of the migrations.
Thank you, Robin. And our next question for you comes from Bob, who is in Good Springs in the US. He says, really enjoyed this presentation. Thank you, Robin. We saw a humpback whale on an Alaskan cruise with Viking in 2019. It was absolutely amazing. But his question is, why and how are dolphins the most intelligent animal in the world?
Well, first of all, I would have to say any statement about which is the most intelligent animal in the world is always ever going to be controversial. We claim and always have claimed to be the most intelligent because, you know, we've invented so much. We have opposable thumbs, we can manipulate our planet and so on. What I'm suggesting, at least with the bottlenose dolphin, is that it has a potential to be as intelligent as us in a different way. And I say that because traditionally, if you like, you know, we've seen ourselves as the dominant species, and we are, you know, we change our planet in a way that no other species is able to do. Whether we're intelligent for doing that is a question in and of itself. We could actually debate that one for the whole evening, of course. But what we've learned about our own brains and other animals' brains, and we've sort of developed brain science, and we understand more about brain chemistry and the complexity of neural pathways, and we can measure the electrical pulses and all of the things we've kind of taught ourselves to do. And initially we said, well, this proves it because we've got all of these amazing features in our brains. But as we've applied ourselves and learned more and more about other animals, we have learned that actually a lot of these brain features that make us so intelligent are also present in other species, and that, you know, that they do have, a lot of creatures do have a language of sorts. It's not the same as ours. So as you particularly asked about bottlenose dolphins, because we could talk about apes and elephants and, you know, dogs, cats, pigs, all sorts of other things as well. But in the case of bottlenose dolphins, they have a brain with a neocortex which is more complex than ours by our own measurements of our own brain, which would suggest that they have an understanding, you know, they have empathy, that they have an understanding of past, present and future. They certainly are far more capable than we are of processing sound. So the sonar that they have, you know, we only invented sonar late 1930s, early 1940s to try and help us track submarines. And it was very, very, very crude at the beginning of the Second World War. Even now, it's debatable whether the amazing sonar technology we have now is as good as dolphins and sperm whales have had for millions of years. And, you know, again, another debate to be had there, because we don't fully understand everything they're capable of doing. But, you know, we've learned that the bottlenose dolphins give their young ones names. We don't call them names as scientists, but that's in essence what they are. They have a signature whistle, is the term that's used, and the mother gives that to its offspring as soon as it's born, uses it constantly in communication with it. The baby learns to say that sound back so its mother knows where it is. When dolphins leave the pod, amongst the signals they send is their own signature whistle, so the pod knows where it is. The pod will use that signature whistle to call it. Now, we can't decipher all of the sounds yet. We don't know what all the other sounds mean, but, you know, there's clearly communication going on. And if you observe the dolphins' behaviour when they're whistling and communicating, the group's behaviour changes. You know, maybe one group will peel off, or the big males will come round and protect the females and the youngsters, or whatever it happens to be, or they'll go off and hunt somewhere differently. And we've also observed species teaching their young and other members of the pod new hunting techniques, which has involved communication and so on. So what I'm saying, I guess, is that, you know, from observing these animals, from knowing what we know about brain science and the potential for intelligence that there is there, as we sort of apply ourselves more to try and understand things in their terms, rather than always applying human sort of human nature to them. Scientists have a great worry always about anthropomorphizing, as they call it, applying human characteristics to animals. But what's increasingly evident is they're not all human characteristics. They are things, you know, there are some things that a lot of animals also seem to have in common with us, and intelligence in bottlenose dolphins would seem to be one of them. Tool use is another one, actually, I'd throw in there. Bottlenose dolphins have been seen using tools to help them with hunting, to protect their snouts. They use seaweed in games of chase, which they seem quite sophisticated sometimes. Yeah, and again, we could do a whole talk on intelligence in cetaceans, but I hope that's given you at least some answer.
Thank you, Robin. And we've had a comment come in from Mike, who is in Houston, who he says he always enjoys your outstanding presentations, whether they're on board or here on Viking TV. But my next question for you comes from Lucille, who is in Canada, in Winnipeg. And she asks, will overfishing eventually cause whales and other species to become extinct?
Well, potentially, yes. And it's threatening whales and other species, as you said in your question, very, very much so. Even in parts of the world where we are at least trying to restrict fishing and manage what we call fish stocks. There's actually just literally yesterday, I was reading a piece about fishing in the EU. And, you know, the EU has a fairly strong fisheries policy, as a lot of other countries do as well, including the US, Canada, lots of places have tried. And we're overfishing more than 40% of those by the EU's own admission. So it is a massive problem. And in some parts of the world, particularly in the deep oceans, fishing is totally unregulated. The UN is trying to get international agreement for some kind of regulation of what we call the high seas, the area outside of territorial waters. But yes, in areas where fish stocks decline, so wildlife declines. So, you know, there are whole penguin colonies which have disappeared because the fish that they could rely on are no longer there. They've either been overfished, or added into that issue is climate change, which means that everything that lives in the ocean is sort of moving to other areas. If they're not tolerant of temperature changes, if the water warms up, some animals have to move until they find water that's cool enough to live in again. So the combination of those two things, and you know, the fishing is one we can do something about if we choose to do so. But it will take two things. One, it will take consumers to either reduce the amount of fish they eat, which means heading towards a vegetarian diet, obviously, at least partially, if not entirely, but also trying to choose fish which are fished in a sustainable way. If consumers do both of those things, or would be prepared to pay more for their fish in order that fisheries could fish with more sustainable methods. So rather than using giant trawlers that scoop everything up, have smaller boats with nets which have sort of traps and things in them to let out creatures which aren't supposed to be caught, and so on. But that comes with a cost, and people who make their living from fishing clearly can't afford to spend a lot of money on expensive equipment unless they can actually make the money in the sale. And of course, we all want the cheapest food that we can get. We want good food as cheap as we can get it. So there's a sort of a balance to be struck, if you like, between dealing with problems like overfishing and what we are prepared to pay in order to make that possible. But if we don't, it won't just be whales, dolphins and animals that suffer for it. We will too, because there will come a tipping point when suddenly there'll be nothing there. And it's happened in places. I mean, the famous one is Canada, when the cod fishery just suddenly collapsed, entirely due to massive overfishing, not mainly by the Canadians themselves, although partly culpable, but by fishing fleets from all over the world going into those waters where it looked as though there was enough cod to last forever. And suddenly, over 4 or 5 years, that fishery just collapsed completely. And now, I mean, it's 30, 40 years later, it's still not even close to being anywhere near what it was before, despite a lot of protection since. And they reckon it could be another 20 or 30 years before there'll be an even half decent sustainable fishery there. So yeah, there's a lot of concern out there if we don't do something quickly to act and control the amount of fishing that there is, and not just the amount, but also controlling the type of fishing that there is, because sometimes it's not just the amount of fish that's caught, but it's all of the what we call the bycatch, all the other creatures that are caught with it, including whales and dolphins and turtles and sharks and all the things that are not wanted. And one of the problems with the decline in the right whales, mainly caused by the original whaling industry, but is now also a problem because they're coming into contact with fisheries and getting trapped in nets and wrapped in crab and lobster pot lines. So yeah, great question. Not an easy answer, but it's in our hands. And when I say our hands, I mean humanity in general. And we've got to choose whether we're going to do something about it. Thanks for the question.
Thank you very much, Robin. And our next question for you is a little bit off topic, but I thought we'd ask it anyway.
I don't mind.
But it comes from a gentleman called Domenico, and he's in the United States. And he has asked, what kind of sea fauna tend to inhabit shipwrecks?
All sorts of different things. I mean, wow, that's a massively comprehensive question. Shipwrecks, particularly those that have been deliberately put out there, cleaned up, and oil and contaminants and poisons and things taken away from, as the question suggests, make absolutely fabulous reefs and homes. So, I mean, literally anything that lives in the ocean that can fit inside it will do. Quite large fish species will take shelter in there, but sharks, for example, know that there are often fish shoals in and around wrecks. So if they can possibly swim in and through there, they will go in there as well. You get large fish like eels in little corners of wrecks, but crabs, starfish, lots and lots and lots of different schooling fish. Only really the very largest animals, and animals like whales and dolphins that don't sit in one place but travel around. Everything else, all of the different fish and crustacean species and so on, will take advantage of wrecks and things if they can. And of course, having seen that, it's why in places where there has been a problem for marine life, why we've had these programs where wrecks and things have been sunk deliberately. Ships have been sunk to create artificial reefs, clear them of all of the contaminants first, obviously, and actually just related to that, it's not directly the same question, but we have put other things down there. So I mean, aeroplanes are used sometimes as well. But one of the great ideas some years ago, a few decades ago, was to put chain a lot of tires together and put tires down there to create artificial reefs, which seemed like a really great idea. But unfortunately, tires have an awful lot of chemicals in them, and what's been discovered is that the chemicals, as the tires wear with the sea rubbing against them and creatures and things growing on them, the chemical contaminants leaking out of the tires are causing more harm than they've done. So we're now having to undo a lot of the tire reefs that were put down there because they're actually being harmful. But no, if done well, shipwrecks, wonderful home for all kinds of marine life. And related to that, it's worth pointing out as well that although while they're being constructed, the construction of wind turbines at sea can be quite disruptive with the drilling and the explosions while the posts are being put in and so on, although you can mitigate that again with technology if you choose to do so. Bubble curtains and ablative shields around them to stop the noise travelling. Once they're in place, those big wind farms are similar to a ship, are a wonderful new reef. Marine organisms attach themselves both to the post and the seabed around it, and of course larger vessels are prohibited from sailing in and around them, so it provides almost like a little marine reserve. So yeah, really good question, and yeah, the really useful artificial reefs.
Thank you very much, Robin. And our next question is the last question for today, because it will be all that we have time for. But it does come from Barbara, who is in Atlanta in Georgia. And she asks, which are the best Viking itineraries for whale watching opportunities?
Oh, wow. Well, it obviously does depend partly on time of year and where you're going. Obviously, first thing I'd say is the longer you're at sea and the more sea days you have, the better chance there is. Some itineraries are very port intensive, so it only gives you the option of doing whale watching as you sail into and out of ports, which can be a very good time, I would say. A lot of places in the world, you know, there are dolphins, particularly in coastal areas. But the real hotspots in the North Atlantic, certainly Iceland, Greenland, anything in that part of the world in the summer months, really nice itineraries. I'm doing the Eastern Seaboard Explorer next year in about August time, and I've mentioned I've been on the Wake of the Vikings, which they don't do anymore, but there is a similar itinerary which goes from Bergen to Iceland, Greenland, across to Lonzo Meadow, and then into the Gulf of St. Lawrence. Fabulous, that's fabulous, but all the way down the eastern seaboard in the summer and the autumn, really good. Alaska, any time of year that they're doing Alaska is always good. If there's anything that covers Hawaii in the winter would be useful. But again, Australia, going the other end of the world, Australian itineraries, the round South America itineraries, there are blue whales in the Chilean fjords. I mean, I saw and photographed blue whales in the Chilean fjords. There are sei whales there, there are humpback whales there, half a dozen species of dolphins, some of which you can't see anywhere else in the world, or at least in very few places in the world, in one or two cases. So they're absolutely fab itineraries. But seriously, and I do mean this, anywhere you sail, almost anywhere in the world, you've got a chance of seeing some whales and dolphins. Some places obviously more focused than others. So if you can get somewhere where the feeding grounds are or where the mating grounds are, and time a cruise to actually match with it, that's always going to be your best opportunity. But yeah, I mean, those are the places I would particularly mention, but I mean, I could list a lot of others as well.
Thank you, Robin. And that's all the questions we have time for today.
Well, that's been wonderful. Thank you so much. I mean, there were some really, really good questions there. And if you've not had time to ask them, I'm very sorry that we've not been able to get to you. But hopefully somewhere you'll get to see me in person and ask those questions on a cruise somewhere. I certainly hope so.